So we're still in Unit 5, and now we're going to go over some of the balancing word equations. You should have out the notes that we've taken in class on the graphic organizer. You should also have out the activity series that we covered and went over on single replacement reactions, and then you should have your worksheet. I'm going to go over some of the examples with you. Let's go into the reaction between hydrogen and oxygen. Okay, so if we're looking here, I've written out the reaction and forcing you to practice Unit 4 again. So here it says reaction between hydrogen and oxygen. So it's saying between those two there is a reaction. These are the reactants. Don't always assume that I'm writing the reactants first. However, in this case it's saying that. So I'm going to write down hydrogen and oxygen. Hydrogen and oxygen are two of those 7 diatomics, so you must write a 2 as a subscript. It's producing water. I didn't talk about what the types are. These are nonmetals, so they are gas, and if you want to get in the habit of starting to write those little symbols, you can do so. It isn't required for Unit 5, however, it will be required for the upcoming units, so you can start to practice that. It is producing water, which is H2O. You also need to write a balanced chemical equation. So with this, we need to make sure we balance it. So I will have my 2, and then I'll put a 2 here, and it's balanced. And then the big question is box in the type of reaction? That is everything with Unit 5. So balancing and writing the types of reaction. If we're looking back and forth on our notes, you'll notice that the notes of synthesis shows you that you have some atom or molecule, and some other atom or molecule, and you're combining it to make a larger atom or molecule, which is exactly here. So if I were going to write that in, let me get my pen again, I would have A plus B is yield to AB. So in fact, this would be considered a synthesis reaction. I'll box that in to denote that that's the type of reaction. So I'm going to go over some more examples from this worksheet. Let's go to the third one. I'm going to try to do one of each of the top 3 types of reactions. Number 3 says representing the heating of magnesium carbonate, which produces a powder magnesium oxide and carbon dioxide gas. So there are states of matter that are listed, so I'm going to go ahead and write that in. So it says the magnesium carbonate, again, erase that. Magnesium carbonate, we have +2 and -2, so we're going to crisscross cancel those out. It's produced by heating, so I'll use the heating symbol that we learned in our lesson last week. And then it produces a powder of magnesium oxide, again +2 and -2, so they cancel out. It's solid powder, so I'll put a little S there. And then we have carbon dioxide, which is a molecule, and it's a gas, so I'll put a little gas symbol. Again, we're just getting used to what a true chemical reaction would look like. When you're looking at your graphic organizer of notes, let's take a look at the second equation. We have a large molecule, or second type of reaction, excuse me. A large molecule breaking down into 2 smaller molecules, which is exactly what we see right here. We have a large molecule, magnesium, and we get breaking it down into 2 smaller ones. In this case, we have breaking them down into a part of A and a part of B. But the main thing that you're looking at is that your decomposition, you're decomposing it from something large into something smaller, breaking them down. So in this case, it'd be considered a decomposition reaction. Let's go down to number 7. Let's take a look at number 7. A reaction for silver nitrate and copper metal yielding silver and copper 2 nitrate. So we have silver nitrate from last unit. We can crisscross the +1, -1, and we have copper metal, so it's just copper, and it yields silver which is a metal, just written by itself. And it specifically says copper 2 nitrate. So we will write copper nitrate is -1. So then we need to use the parentheses and put the 2 on the outside. Again, that's from Unit 4. Then from Unit 5, we learned that we needed to make sure we balance these equations. I have 2 nitrates here, so I'm going to put a 2 in front of the silver nitrate, which means I need to put a 2 in front of silver in order to balance it. Looking at our graphic organizer, going back and forth, let's go down a little further here. We'll notice that the swapping is occurring. So if there's some sort of swapping and there's a single replacement, there's another thing we have to consider to make sure that this reaction occurred. So the question is copper, oops, it jumped up again, I apologize, is copper more reactive than our silver? Well, let's take a look. I'm going to bring up the activity series. So here we have copper. Is copper, this is the one at question, this is the last unit question, is copper more reactive than silver? And yes, it is. So copper can take place, it's underneath, so it can bump off or swap, and this reaction can occur. So that's something that we need to consider. And in this case, we can just label this as single, and I keep jumping up here on my screen, I'm sorry about that, single replacement. Okay, we can also shorthand single replacement to be SR. That's acceptable. All right, so I had asked you to complete the rest of the reactions here and check your answers. You can actually hold off until Thursday and Friday when we get back to class, because this is a double replacement reaction, and we'll be working on that in class. So you can skip this and types of reactions. We're going to go over the graph.